Right guys, I'm going to quickly show you how to get this motor turning without the trigger winding, so just run from the factory holes. It's really quite simple. Just install your factory hall sensor if it's not already there. It'll come with 4 wires. I'm not too sure the colours will be universal, but if you get this Samsung direct drive motor, the same motor that I'm using here, it will come with the exact same hall sensor. So white, positive, the first wire is positive, second wire is your negative, and the other 2 wires are your signal wires. So what that means is you apply a voltage to your positive and negative, and when a magnet passes the sensor, it'll either allow that voltage to travel through that signal wire. So our signal is going to be the 15 volts that we supply if we choose to use 15 volts. So when a magnet passes this sensor, voltage will travel down that red line and with the blue one also, but we're only going to focus on the red one, or the third wire, because we only need one signal, and that is whether or not there's a magnet passing here, this coil. So when a magnet passes that sensor, it'll switch that signal on. When the magnet passes it again, I'll switch it off. When the magnet passes again, I'll switch it on, and that cycle repeats. That's how we're going to do our switching from now on. Whereas beforehand, there was a trigger winding on each leg to do that, which was causing a lot of current on our gate, which wasn't helpful at all. So to rectify that, what you'll need to do is connect the negative to the emitter of the transistor to here. So that'll be your negative, which is the second wire, the grey one, as you can see here. So that'll go to the emitter of your transistor, which is here. The positive goes to your 15 volt supply, which is separate from the input voltage. Unless you want to create some circuitry, you can do that easily. You could even power this 15 volts off of here, and I've done that before. It works pretty well. You can keep your gate winding on there if you've got your trigger winding, sorry. If you've got a 10-turn trigger winding on there, you can keep that on there and use that to power the hall sensor, but you need to give it a spin first and have it rectified. So just to get a nice clean DC 15 volts, I'm using this old Wii adapter. It does the job. It's 15 volts, so it's exactly what I need to be. Pin number 3, that's the signal, so you want that to be on the gate, because that's what's going to trigger the transistor to switch the current from here to here, which will allow rotations on the motor. So this drawing here is only the power coil. There's no generator coil here or anything, just to make it simple, but those coils are here. It's really, really simple. So 1, 2, 3, 4, 5, 4 hall pins, but we're only interested in the first 3. Positive, negative, signal. When a magnet passes a hall sensor, it'll trigger that signal. It'll switch. The magnet will switch the hall sensor on, and that'll allow that 15 volt supply across the gate. And when the magnet passes by, it'll switch it off again basically just doing the exact same thing the trigger winding was doing, except from this is far more efficient. Like I said, it's super simple once you get the hang of it. Alright guys, so I just quickly paused the video and put the rotor back on now. Return it. As you can see, it's not doing anything. The power's connected to the supply, but nothing's happening. And over here you'll be able to see the bulb's not lit, even though the power is fully connected. The only thing that's stopping it from turning on is because I haven't switched this 15 volt supply on the circuit there. That's the only thing that's stopping it at the moment, but it is fully connected to the power now. This bulb should not be lit, even though it's connected to the power. If this isn't turned on here, this bulb should not be lit, and this should not be moving. It shouldn't be stiff, it should just rotate freely with no resistance, really. So all I'm going to do now is just going to plug this in. I'm going to see what happens. Alright, so we've got rotations there. All I did was plug in the 15 volt supply now. I can unplug that and then plug it into the generator. So the gate voltage is now just running off the generator supply now. Let's see if you can see it a little bit. So, alright, there we go. That's the 15 volt supply there. Here, this grey box, it goes to, the positive goes to the first wire and the negative to the grey wire. Now remember, the negative of the grey wire goes to the negative of the 15 volt supply as well, and the emitter, and just remember that in mind. So now, at the minute, this 15 volt supply is coming from this adapter, which is plugged into here, the generator. So I'm going to switch it off, or switch only this 15 volt supply off, and we'll see what happens. Now this does store a bit of energy for a good 30 seconds or so, so we'll wait for that to switch off. There you go. What's that? Won't turn on, but the power's still connected. Just switch this supply off.